DNA replication!
The oxyribonucleic acid is the molecule that carries most of the genetic material in an organism. This is how it is replicated. First, hydrogen bonds in the middle of the DNA strand are broken by helicase, an enzyme necessary for DNA replication. Once the bonds have been broken, a replication fork, the point at which a DNA molecule is replicating, is created.
Now that the strand is split, primase, an enzyme that catalyzes the synthesis of a primer for DNA replication, comes in and starts the binding of DNA nucleotides by adding a primer. After the primer is done, polymerase III, another enzyme that catalyzes the formation of DNA strands, comes in and synthesizes the DNA strand. This is the origin of replication, the point at which helicase unwinds the DNA double helix and DNA polymerase binds to initiate DNA replication.
The leading strand, the strand that is synthesized continuously, and the lagging strand, the strand that is formed in discontinuous stretches, are formed slightly differently though. The lagging strand is formed by many small fragments, called Okazaki fragments. The reason the leading and lagging strand must be formed differently is because the top and bottom strands of the DNA must be anti-parallel. The part's molecular orientation must have opposing directions. DNA, however, only synthesizes in the 5-3 direction, which is no problem for the leading strand, but the lagging strand is on the opposite side and needs to be in the 3-5 direction, so that it is anti-parallel to the leading strand. DNA, however, can only synthesize in the 5-3 direction though, which is why the Okazaki fragments are created and used.
Once the base pairs of the DNA strands are attached together, DNA ligase, the enzyme responsible for uniting broken DNA strands during replication and recombination, glues the base pairs together. This creates one new chain of DNA and one old chain of DNA. This is called semi-conservative replication, where half of the newly crafted DNA strand is from the original DNA and the other half is made new. Lastly, the DNA is checked for errors that may have occurred during the replication process. Now you have completed the DNA replication.